There's probably not an adult alive who hasn't had the experience of seeing an acquaintance for the first time in years and being shocked by how old that person looks. The shock reminds us that we, too, are aging. We don't see the signs as clearly in ourselves, even though we see our own faces and bodies in the mirror every day, because the changes occur so gradually. It's only when we encounter someone we haven't seen in a long time that the recognition of our own inevitable mortality strikes with unpleasant force. While we notice wrinkles, bifocals, and other visible manifestations of aging, we tend to overlook the many internal factors that control the rate at which we age. Just as we can measure more readily seen characteristics, we can also monitor our own aging by assessing our biological terrain, the totality of our internal biochemical environment. Taken together, these factors are the biomarkers of aging. A biomarker is a measurable chemical substance or physiological value that is known to change over time. By improving our biomarkers, we improve our health in general and our DNA repair and longevity in particular. Some biomarkers are objective, that is, they are measurable and not subject to opinion. Others are subjective. They depend on perceptions rather than verifiable facts. Some biomarkers can be modified, while others cannot be changed. This chapter discusses a variety of biomarkers and describes the significance of the information they provide. Later in the audiobook, you will learn techniques to modify and improve many of your biomarkers. Objective and subjective biomarkers. Objective biomarkers provide hard data, measured and documented with standardized and accepted laboratory technology. They can be considered direct measurements of gene expression. Changes in the functions of genes and the proteins they produce are responsible for creating the molecular changes that we see in objective biomarker measurements. Some of the more important objective biomarkers that determine quality of life, as well as appearance, are the secretions of the endocrine glands. These glands synthesize hormones and deliver them directly into the blood or lymph, through which they are circulated to all parts of the body. The endocrine glands include the pituitary, thyroid, parathyroids, adrenals, pancreas, and the sex glands, the ovaries and testes. The lining of the gastrointestinal tract also performs endocrine functions. The hypothalamus produces hormones that affect the production of some of the endocrine hormones. These hormones will be discussed later in this chapter and explored in greater detail in Chapter 5. Each hormone has a specific effect on some part of the body or a general effect on the body as a whole. Its presence in our systems in sufficient quantities and its relative balance to other hormones is crucial to the quality of our lives. Too much or too little of a specific hormone is apt to trigger an excess or deficiency of some or all of the rest. Hormones both affect and are affected by gene expression. A hormone panel, performed in a laboratory on a blood sample, is the way the relative balance of endocrine hormones is measured. Any physician can draw the blood and order the tests, but the analysis of results as they affect aging is usually best done by someone skilled in the